Oops. Okay. All right, so if you open up the file, it's called, so in the suspension1 directory, which is online, it's proj1, proj_1, which is this part here. So, all right, so what we're going to do is, the tutorial actually is pretty easy to follow. It's pretty simple. So it just contains the tire, the lower arm, which is this, the rack and pinion steering housing, which is this guy here, the steering rod, which is this purple one here, the upper arm, which is this, and the knuckle, which is this red part here. So those are the parts that are contained in here. And this one already has the joint set up. It already has the even driver set up. And so we're just taking that setup and then running an analysis on it. So it wants us to start the simulation. So if we, all right, so if we go start motion simulation, so we're in the motion simulation and we want to do the motion 2. Oh my, let me just try. So it mentions there are two joints, J007 and J008, which are both drivers, and so they we'll be using those. The J007 in the picture on page 4, one of them moves the suspension up and down, moves everything up and down, and the other one pushes this in and out to turn the wheel. All right, so let's go to motion simulation, and let's hope this works. There we go. Okay, so here we are now in the motion simulation, and so we're going to do something called trace. So from, where do you go? Right, this button here. Drag it down. Oh, great. XNX. So this interference button, we're going to run a trace. If you, right there, or not the interference, but the drop down next to it. Okay, now it says the target layer lets you specify the layer that will contain the results of the trace. So they've already created several layers, and so they tell us to use layer 5, which they've already left open to put these traces into. It says leave the make active checkbox and make sure the reference frame is set to absolute, right, which is what we want. Okay, now you need to select an object to trace. We are going to trace the tire. So if we select the tire body, this one we just want to select just this one body. So we're going to set up an articulation. So we're going to apply step values to the joints with the motion. So we're going to tell it to step a certain number one way and the other way. So we're going to create a new articulation solution. So just like we did in FEA, if you right click and you say new solution, right? So we right click on motion _2 here, right? And we say new solution, and then the solution type, we want it to be an articulation. And we want to make sure the solve with OK is boxed, so when we click OK, it'll just solve it. And the tutorial says to leave everything else default, and we just click OK. And so now it's creating a new articulation solution. Okay, now it said it found these two driver joints, and so we're going to use the driver joint J008, which pushes these rods, which will then turn the wheel. and it tells us to put a step size of 10 and to put 5 steps. This says that the step size is 10 millimeters, and 5 steps of 10 millimeters will make this move 50 millimeters. And we can, we can check the, and then so we can check this by clicking step forward, and we'll see that it moves the 50 millimeters, and we can step it backwards as well. And you can also hit this button, which is assembly position, which will snap it back to the original position. Now, if we go, all right, so down, if you hit this green arrow down here, more options, under the packaging options, now if we click the trace button, and then if we click forward, it'll cause it to step forward 5 times, but it'll create a new part every time it does that. And it saved those parts into layer 5 like we set it up to be. So now if we click on assembly position, it'll snap back to the original position without retracing them. And if we trace backwards, it'll make 5 more that way. So now we have several copies of this tire on layer 5 that shows how far it moves, right? All right, and cancel. Okay, so, all right, we wanted to go back to that. So let's go to solution, attributes. So back in this box, okay, so we are here again. Now we want to continue the trace analysis. So if we go and unclick trace, and we change which driver we want. So instead of using this driver, we're going to use the vertical driver. So if we take this off and turn on the other one, and the tutorial says, suppose you have calculated the maximum travel distance to compression for the suspension is 50 millimeters. So in that case, we're going to put 10 steps or 10 millimeters for 5 steps of this driver. So it's going to push this up 50 millimeters, right? And so if we step forward, it'll show the suspension moving upwards, right? And so now we are going to, and at this point it has a note. It says make sure to only click step forward once to avoid solver lockup. So it looks like in this simulation, if you were to click that again, it's going to try to go too far and it's going to lock up the solver. So just make sure you only do that once. Now we want to rotate the tire up here as if it's at full compression. So we're going to turn off this driver and turn on this one again. And we are going to reselect trace. And then we're going to do the same thing we did before. We're going to step forward. And then we're going to snap to assembly position. And we're going to step backwards. Oh, whoops. Moved down. We're going to have to move this one back up forward. There we go. And now if we trace backwards. Oh, whoops. That didn't work. Right, now if we trace this backwards, or forward actually, not too far. Okay, I went too far on that. But if you do this, you can see the full range of motion of where this tire, how far this tire is going to move under these given circumstances. So the reason you can do this, at the end of this it says, the trace geometry can be used to establish the size of the fender. The geometry represents the total volume of space required for the tire to operate in the suspension's total range and not touch anything. So that's the purpose of doing this and saving traces, is you can see now how much space this tire is going to take up under the full range of motion. Okay, now we are going to close Alt+. parts. Okay, I'm going to reopen the parts again. You don't have to save it each time because the tutorial is kind of broken into 3 steps. So the first one was that one we did. This next one we're going to do another one. So if we open up this project again, make sure we are in motion simulation, and open this up. Now we're going to see something similar. We're going to look for interference of where, like as we keep turning this wheel, where is this going to bump into it? And it's actually not going to be the tire that hits the lower control arm. It's going to be this knuckle. An area right about here in here is going to run into the green part. So we're going to use the motion simulation to find where that happens. So, and we can turn off these little names if we go to Preferences, Motion, and then we click this Name Display. And that will turn off those names. It asks us to make layer 1 the work part. So if we make this the work part, layer 1, and now we want to use interference. So this is the interference button. And the type, so it says highlight is, it explains what each of them are. Highlight and create solid and show intersection curve. And in ours, we are going to create solid. On the mode list, it says make sure it's precise solid, and explains a few things in the notes. So on stop on event, we want to make sure it stops on the event and makes active. So once it finds it, it will stop where that interference is instead of continuing on. So if we select the interference objects, we're going to select, first it wants us to select the lower control arm, and then it wants us to select the knuckle, that guy. Now, this is important, and it has a note here. The first object, both of the objects should be included in this first set. It's not the first object, second object, but rather both of them are here. And it explains that you use the second option only if you have 2 sets of geometry, such as 2 complex subassemblies on which you want the interference option to act. So probably in all of our cases, we're just going to make sure we select both of them in here. So that's important to note. Now that we click OK, and we're going to create a new articulation solution. So we right-click on our Motion 2 here and say New Solution. And we want it to be articulation. We want Solve with OK to be on there. And we're going to click OK, leave the rest default. And it'll bring up that same articulation box that we had before. We want to make sure Stop on Event. So now it highlights, or it gives us the option of checking these. So we want to select interference and stop on event. And so it says, for this interference check, you will attempt to turn the wheel to the left, which will cause the knuckle to rotate. This rotation will eventually cause an interference between parts. And this solution will find where that interference is, and it will stop. So if we turn on joint 008, and if we leave the step size to 15 and say 5 steps, then it should go far enough that it'll hit that interference. So when we're ready, we click step forward, and we'll watch. And if you notice, it went past, and then it came back, and then it converges on the solution. A part interference has occurred. So it has stopped where the interference was, right about in there. Now it's explained that displacement 47.85 is what the displacement was when it hit. This isn't the angle, this is the displacement of this driver that goes along horizontally. So in the tracing and view creation area, which is this down here, it says click trace entire mechanism. And now it traced and it copied the mechanism of its current position into the work layer. So it wants us to cancel out of this, and we can see the original, which is this, and the moved part, as well as you can see which is original and which is moved. There are 2 copies of this as well. Some of the other parts didn't move, but you can see that. Let's see if I can drag this over. You can see there are 2 copies of everything. All right, so we can use the measure angle